welcome back. I'll continue the next topic. Today's topic is estimation techniques. So more number of estimation techniques are there. In the coming classes, one by one we'll discuss. In the last class, estimation techniques I explained already. So parametrics technique, analog technique, 3-point estimation technique. So life cycle of estimation technique. All these are all completed. Now in this class, I want to discuss about various estimation techniques. Various estimation techniques. Here, various estimation techniques are listed out here. These all techniques are used to estimate the project. These all techniques are used to estimate your project based on some factors they are taking to estimate the product. Okay, so sometimes resource estimation is there, sometimes time estimation is there, sometimes product estimation is there, like that. So they will estimate one parameter they will take to estimate the project. So one by one here some estimation techniques are there. I will explain briefly a few techniques, but overall I will explain all these techniques. Okay, few techniques I will explain. So suppose I want to explain the coming classes, source lines of code I will explain, and function point analysis also I will explain. Next use case point analysis also I will explain. Next cost constructive model. These 4 techniques briefly I will explain in the coming classes. So just overall all these techniques what happened I will explain now in this class. Okay, so one by one we can see that first one. So pure expert judgment. Pure expert judgment. What is the meaning of pure expert judgment? Experts here in the who are involved in the project. So that people are experts. So they are estimating some parameters they will take to estimate the project based on the knowledge, previous experience of the particular projects. So all this considered to estimate the project easy. So pure expert judgment. They will judge the previous analysis and they will judge the previous techniques. What techniques are they using to execute the project, estimate the project. So all these parameters they will take to estimate the project. So pure expert judgment is, so who are expert in our project, that people are giving the experience to estimate the project. That means that. Okay. So this is a pure expert judgment estimation technique. Next one is historical data. Based on the previous data analysis. So that data analysis is the historical data. So that historical data, what method to estimate the projects in the previous projects. Okay. So that techniques we are applying to estimate our project also. Okay. So it means that historical data, old data we are taking, that data how much cost it is previously, in the same cost we are applying in our project also. Suppose for example X project, so 10 activities are there. Here activity 10 activities are there. These 10 activities, suppose $10,000, $100 like. Okay, these are all 10 activities are $100. So here in the Y project, new project, same activities we are taking, same activities, 10 activities. So in our project, Y project also same estimation is there. So it is the advantage based on the historical data. So historical data means A is the historical data. These activities are involved in our project also. So same cost we are estimating. So this is called historical estimation technique. Next, wideband delete technique. So before going to wideband delete technique, so delete technique is there to estimate the project. So it is a forecasting technique. So forecasting techniques, it is same as that of previous data analysis based on we are estimating the project. Here, so wideband means here the previous analysis and the present analysis both are mixing to estimate the project using the wideband techniques. It is also one of the techniques to use the estimation of the project. Okay. Next, kilo lines of code or source lines of code, SLOC or KLOC, whatever it may be. So based on the project code, we are estimating each line. Okay. Each line, how much cost it is, we are estimating either physical cost or logical cost, whatever estimation. Based on the code, we will focus code estimation. So we are estimating the project. So this is the lines of code. I will explain in this class. Next, function point analysis, FPA. Function point analysis. So in the project, multiple number of functions are there. Each function is different cost. Okay. Suppose function 1 is $10,000, function 2 is $10,000, like that. So each function cost, we know that automatically total functional cost we are estimating, and overall project cost is we are getting. Okay. So function point analysis, there are some formulas are there. I will explain in this class. Okay. Next, use case point analysis. How many use cases used in our project? Each use case, how much cost is it? So based on the use case technique, so what use cases are used, so that use cases are how much cost it is. Based on the use cases, we are estimating the cost. It is called as use case point analysis. Next, Mount Carlo technique. So it is also using for web-based projects. We are estimating easily. So Mount Carlo method. Okay. Next, cost constructive model in the SE operating system. In the software engineering. So you know that already, cost constructive model, COCOMO model. So here semi-detached, detached and complex type of projects. The three categories of projects are there. So three categories of projects, we are taking the rough input, so we are getting the total cost of project. Okay, either average projects, small projects or complex projects. We are easily estimate based on the cost constructive model. Next, ninth one is test case point analysis. Already use case is completed. Here, how many test case? Based on the test case, suppose we have 100 test cases are there. Each test case, how much cost it is? We are getting the full total project test cases. How many test cases are there? Each test case, how much cost it is. So all these things we are considered using to estimate the project. And the last one is function point test case. These two are same, I think. Function point analysis and function point test cases. Here we are taking the functions. Here each function test we are considering. So that is the difference. We can see that in a few techniques one by one. So first I will discuss right now in this class I will discuss these two techniques. Source lines of code, function point analysis. So after that we will discuss remaining things. Okay. So one by one we can see that. So here lines of code, SLOC, source lines of code. So generally in our project, any project, so source lines of code is very, very important. Without coding, our project is not executed, right? So here, if you have using the project code, so multiple number of lines, more number of lines to write the program in your project. So here, each program, how much cost it is, each line, how much cost it is, like that we are calculating. But here, we have see that source lines of code are kilo lines of code. SLOC are know that lines of code, LOC, kilo lines of code. KLOC also. KLOC means kilo lines of code. SLOC means source lines of code. It is used to metric the size of the computer program. It is used to metric the size of the computer program. So your project having coding is there. So that code is nothing but computer program by counting the number of lines. How many lines of code you are using in your project. Okay. So either small project or big project or average project. How we are estimating based on the lines of code. How many lines of code you are writing your project, so based on the lines, we are calculating the cost of the project. Okay, so counting the number of lines in the text of the program source code. So either using the text information or logical information, whatever the information used in the program. So each program contains how many lines of code. So that code we are estimating to create our project estimation. Okay. So here generally two major types. First one is physical SLOC. Second one is logical SLOC. Physical SLOC in the sense entire program. So in your program comments is there, in your program empty lines is there, in your program some unused data is there. So whatever the data in your program, that program is calculated each line, it is called as a physical SLOC. So whereas logical SLOC, in your program only logic of the program will be counted. Here spaces and empty lines, so whatever it is considered also here physical SLOC, but here only logical SLOC consider logic of the program. Only executable statements only consider. Executable statements only considered to calculate the project estimation. So we will see that one by one. So SLOC, SLOC and PSLOC, physical SLOC and logical SLOC. So physical SLOC in the sense some specific definition of the two measures varies, but most of the common definition of physical SLOC is count of lines. Count of lines in the text of the program source code, text of the program source code, executing command lines also. So not only execute the lines of code, in the lines of code contains comment lines and empty lines, whatever it is there. So that also consider using the physical SLOC. Whereas logical SLOC, we need not to consider the comment lines and empty lines or unused data. Only logic of the program, it means that executable statements only we are considered to calculate the project estimation. So like that here, logical SLOC attempts to measure the number of executable statements. It is very important. Number of executable statements considered, but their specific definitions are tied to specific computer language. You are using C or Java or whatever the language. So based on the language we are estimating. So in C language you are writing add two numbers program. So some 5 lines are there. You are writing same program in Java, some 10 lines are there. Which is the better language? You can see that. Which is the better language? 10 lines of code is better or 5 lines of code is better? Same logic. We are getting same out. So better to go for C language because of lines of code is less. So based on the lines of code, optimizing code is very very important using in the software products. Okay. So based on the projects only we are using the languages. That is another matter. So but here how we are selecting the language in our program means less number of code is there, you are selecting the language. Otherwise your project is, there may be a problem. Okay. So here the language. Okay. So we are considering this one is physical SLOC, logical SLOC. I will give you the example, small example. Here the common for used lines of code in the SLOC. Here first one is for I equal to 0, I less than 100, I plus plus. This is one statement. Second statement, third statement, fourth statement, fifth statement, sixth statement. Here two unused lines are there. So comment lines and empty statements. These two lines are need not necessary. Just user understanding purpose, we are giving the comment of the program and we are giving the space. They are very much understand to anyone, we are giving the space. So these two lines are actually need not necessary. These two are optional only. So but these two lines are also included, your program is visible very easy. to understand anyone. So like that here. So here how many lines? 6 lines total. This program, how many lines? 6 lines. These 6 lines is considered, it is a physical SLOC. It is a physical SLOC. So here we are consider the command lines, comments of a program, empty lines of the program. Comments and the empty lines also we are considered to calculate the lines of code is called the physical SLOC. Whereas logical SLOC consider only 4 lines. What is the meaning of 4 lines? Here this statement is executed. Line 1, this is the line 1, this is the line 2, this is the line 2, this is the line 3, and finally this is the line 4. Okay? So line 1, line 2, line 3, line 4. These 4 lines are enough to complete your program. Okay? So need not consider 4th line and 5th line because of no use at all. Only executable statements are there, so that will be considered using the logical SLOC. It is very easy. Okay? Physical SLOC means we are consider comments of the program and the empty lines of the program. Unused data also we are considering the physical lines of code. But whereas logical SLOC, only the compiler will execute the statements. That is statements only considered to calculate the cost lines of code. So here 6 lines, here 4 lines. Okay. So depends on our situation, our cost. So we are considered, no problem. Okay. So this is the example of using SLOC estimation. Okay. Source lines of code estimation. One more example. Here we are using C language. We are using COBOL language. COBOL and C language. In the C language, line 1, line 2, line 3, line 4. 4 lines are there. Total lines of code is 4. Okay. Here in the COBOL, it is line 1, line 2, line 3, line 4, line 5, line 6. Total how many lines? 6 lines of code. Here white spaces also considered. Here no need to calculate the white spaces. Okay. It is the difference between the languages also. Okay. Here the C language 4 lines to complete our program. Here COBOL language 6 lines to complete the program. Which lines of code is better? C, because of less lines of code. It is also using for cost estimation. Okay. Source lines of code is important factor in our projects. So based on the lines of code, we are estimating the project cost. Okay. So this is a very example useful. Now advantages and disadvantages. Here the advantages are using the LOC, scope for the automation of the counting. So based on the source code, we are automatically counting. And another advantage is an intent to metric. So it is a very important metric to calculate easily. Ambiguous measures. So any other method, additional methods we are not considered sometimes, we are considered sometimes. Depends on situation we are considered, depends on situation we are not considered. So ambiguous measures we are taking. Now disadvantage is here, lack of accountability. It means that only depends on coding we are estimating the project. Is it right? There may be a right or there may be a wrong. Okay. So lack of accountability, lack of cohesive within the functionality. So in the another projects, though there are many functionalities are there. Registration functionality is there. Some other process functionality is there. Like that. So different functionalities is there. But how do we calculate the code? There may be a difficulty. So it is different. Okay. Different in the language. We are choosing the language is very, very important. So if you are choosing wrong language, your project is cost out of the range. Okay. So problem with the multiple languages. So we are selecting multiple languages in the C language or Java language. So in these languages, which is the better before estimating the project, we want to check, otherwise there may be a problem. Next, lack of counting standards. So sometimes there may be any line is missing, that cost is degraded. Okay, so counting problem is there, so we have to easily count, otherwise there may be a problem in your project. So this is the source lines of code estimation. Okay, SLOC estimation, source lines of code estimation. We have two types: physical SLOC, logical SLOC. We are executing the, you are estimating your project. Now the second technique is function point analysis, FP. Function point analysis. The project contains multiple number of functions are there. Okay, each function cost we know that. Okay, so total multiple number of cost we are estimating easily. So here function point analysis is in the 1970 at the IBM, and it has been further modification by the International Foundation Point Use Case Group, IFPUG. They are developed one function point analysis. Function point analysis, FPA, is a method for set of rules of a function size measurement. We are estimating the size of the project based on the function point analysis. It accesses the functionality delivered to its user based on the user external views and functional requirements. External views and user external views, and also data type we are checking. It means that functional requirements, based on the requirements we are consider the function point analysis estimation. You can see that the external views here, type of function point analysis. First one is transactional functional type. Second one is data functional type. Transactional functional type and data functional type. In the transactional functional type, three type of functions are there: external input, external output, and external enquiries. External inputs EI, external outputs EO, external enquiries EQ. Suppose here this is the function. Okay, here external inputs means here outside of the function will give the inputs to the project. External inputs. External outputs means we are taking outside of the project external outputs. Okay, here like that. Okay, external enquiries. You can see that elementary process made up of the input and output, both input and output combination, the results data retrieval. Input and output based on we are calculating the data retrieval. So internal external input means a process data or control information that comes from the outside. That comes from the outside. It comes from the outside of the project, outside of the application's boundaries. The EA is an elementary process. External input is an elementary process. External output is an elementary process. This is also elementary process that generates the data or control information set outside the application boundary. Outside the application boundary. And whereas third one is external inputs. EQ is an elementary process. It is also an input and output combination. We are getting the results. Next, second type is data functional type. Data functional type. Here, two data functional types are there. First one is internal logic file, external interface file. Interface file, internal logic file, external interface file. Both are different data functional types. What type of data functional types are there? Internal logical file, external interface file. Both are there. Very, very important. So here, internal logical file, the user identifiable, a group of a logical related data. The user identifiable, the group of logical related data or control information maintained within the boundary of the application. Maintained within the boundary of application. This is called as internal logical file. Now, external interface file, a group of users recognizable logically related data. Logically related data only. Logically related data allusion to the software, but maintained within the boundary of the software, another software. Maintained within the boundary. Otherwise, no need. Okay. So, maintained within the boundary, we are taking the internal, external interface files. Okay. So, these are the data functional type. Transactional functional type, transactional functional type, data functional type. These 5 inputs are very, very important using to calculate estimation of function point analysis. So, one by one we can see that. In general, every project we are consider 3 parameters. Low type of project, average project, high type of project. It means that here small, average, complex projects. So even we are taking the attributes of the project, okay, weights of the project, okay. So multiple number of attributes we are using. So all the attributes, how much cost it is, either the range of 15, within the 15. So suppose you are giving the weight 7, 10 or 15. We are taking randomly. Actually depends on project, we are giving the input. Suppose number of external inputs we are taking low level project is 7. Number of internal inputs we are taking average project is 10. Number of internal inputs we are taking high level project is 15. Okay. So here the highest range we are taking 15. Suppose here you can see that number of external outputs we are taking in the low level project is 5 only. Here we will take 7 only. Here we will take 10 only. Like that we are calculating all this estimation. So if you know this table, then only we can easily calculate. Otherwise we can't calculate easily. So these ranges are very, very important. So internal, external inputs, external outputs, external inquiries, and internal files, internal, external interface files. So these are all very, very important. So we are taking randomly, no problem. Only you have to take only this one is fixed 15. Do not consider. Depends on project. We are giving the external inputs is some number. Okay. So just roughly we are taking this one. Okay. You can see the output. The functional point FP is those calculate within the following formula. FP is equal to count the total number of lines multiply this value we are applying. So first we know that the total number of lines of code, then only we can multiply this number. What is that number? 0.65 plus 0.01 and multiply again F5. What is the meaning here? So total actually CAF. This number is CAF. What is the meaning of CAF? Here count the counting analysis formula. Counting analysis formula. Here, whereas CAF is F5 means sum of all the 14 questionnaires. Okay, F5 means sum of all the 14 questionnaires. And the next one is our range. Giving the range is 0.65 to 1.35 because suppose you are giving 0 to 0.65. You are here. Suppose Fi is 70, then 0.65 plus you have multiplied this number 0.01 to multiply 70 because we are taking 70. We are taking 70 is the number. Okay, so that's why we are calculating 0.65 plus 0.7 because of these both are multiplied. We are getting this out. Okay. So after that 1.35 we are getting. So actually these are the ranges we are taking. Why we are writing the 0.65 and 0.01? This is the range we are giving. Okay. So this is the starting range. This is the ending range. Okay. Starting range we are giving here. In the ending range we are not giving, so just we are multiplying 0.01 multiply. If we are getting 70% of range, that's why we are giving. Otherwise, no need. Just 0.01 we are giving to calculate the function point analysis. These formulas are very, very important. Okay. So remember these all points. Very, very important. These formulas. Okay. The value adjustment factor. FA value adjustment factor. VAF value adjustment factor. Okay, VAF is equal to TDI multiply 0.01 plus 0.65. You know that these two numbers already here and here. Okay, these two numbers we are taking. Okay, TDI multiply 0.01 plus 0.65. Here, remember the value factor is range 0.65 to 0.35, because I told you already here the range 70% you are getting 0.01 multiply with 0.7, we are getting 1.35. That's why here I am writing 1.35. Okay. Then TDI is equal to 0. Initially we are taking TDI is equal to 0. VF value factor we are getting how much it is 0.65. Then when TDI is 70%, so automatically we are taking 1.35. If you are taking initially 0, 0.65 is enough. If you are taking 70%, 1.35 we are getting. Okay. So VAF is the multiple with the UPF to get the final function point count, UPF. So now the total formula is this one. Okay, it is very, very important. Now the function point analysis is equal to value adjustment factor multiply VFP. Okay, use case point factor. Use case point factor. UFP. Use case function point factor. Okay. So this is the formula we are estimating easily function point analysis. Thank you.